The course for a boat race starts at point A and proceeds in the direction of south 52 degrees west to point B, then in the direction of south 40 degrees east to point C, and finally back to point A. Point C lies 8 kilometers directly south of point A. Approximate the total distance of the race course. There's a lot of stuff going on here, but we're just going to draw a picture. Starts at point A. So here is point A. And it proceeds in the direction south 52 degrees west. So from the south line, it creates a 52 degree angle to the west. So here's a 52 degree west to some point B. Then it goes from the south 40 degrees east. So from there, it creates an angle of 40 degrees. 40 degrees right there towards the east to some point C. And then back to point A. And we know that point C lies 8 kilometers directly south of point A. So we've got that connection right there, and that is a length of 8 kilometers. We want the total distance of the race course. So we're looking for all the side lengths so we can add them together. This is side angle. Okay, we don't quite know this angle yet here, but we can find it fairly simply by thinking of some right triangles. If we connect that directly over, get a right angle there, then we can use the fact that the sum of the angles here in this right triangle is 180. So this angle right here will be 180 minus 90 minus 52. And we get 38 degrees for that angle, 38. And then this angle over here, we can see that we form a right angle with the 40 degrees in that. So this right here is 50 degrees, which of course tells us that the angle B is the sum of those, which is 88 degrees. And our picture, actually, I'm pretty proud of myself here. This picture is pretty close to a right angle, which is, 88 degrees is super close to a right angle. So we've got angle B, and so we can get angle C. And angle C, of course, is 180 minus the angles A and B. So minus 52 degrees minus 88 degrees. And that gives us, 40 degrees for angle C. 40 degrees. That, of course, actually is super obvious. I didn't even think about that. But we have the north-south line here and this north-south line here. Obviously, alternate interior angles are equal. All right. We've got our angles B and C, and of course A. We've got all three angles. We've got this side length A. We can use the law of sines to find the other two side lengths. Let's start with finding the side length A. So A over the sine of the angle A, 52 degrees, is equal to 8 over the sine of the angle B, which is 88 degrees. And I'm going to finish out the law of sines just so we can see it all there, equals the side length C over the sine of the angle C, which is 40 degrees. And now we have these two different equations to solve. We can solve this equation for A, and we can solve this equation for C. So for the first one, we multiply by sine of 52 degrees. We get 8 sine of 52 degrees over sine of 88 degrees. And let's go ahead and plug that into our calculator. 8 sine of 52 over sine of 88. And we get about 6.3. So about 6.3. And for the second equation, to solve for C, we multiply by sine of 40. So we get C equals 8 sine of 40 degrees over sine of 88 degrees. And go ahead and type that into our calculator. I'm going to go ahead and cheat and then just edit. Copy that and edit it. 8 sine of 40 over sine of 88. And we get C is about 5.1. About 5.1. Okay. We're looking for the approximate length or total distance of this race course. So we're just going to add our lengths together. So we've got 8 plus, and I don't actually need to use the rounded forms. I can just go up and add both of those, plus, okay, those two lengths. And we get, rounding to, now for our final answer, rounding, we get about 19 point, I'm going to round to 2 here, 0.45. And this is, of course, in kilometers, since that's what our lengths were being measured in.